It's John Robb here, interviewing Stephen Brusatte, author of a fantastic book about dinosaurs, the rise and fall of the dinosaur. Great deep dive into the subject, but also written very understandable pop cultural terms and a very entertaining read. I mean, was that what you were trying to do with the book?
Well, first of all, thanks, John. I really just appreciate the nice things you say about the book, and I'm glad it was on your radar. And that's exactly what I wanted to do. I wanted to write a book about dinosaurs for a big audience, for a general audience, for mostly for adults, but for teenagers too, not just for kids. There's so many books about dinosaurs for kids because I think often dinosaurs are still seen as kind of a kid thing. It's a phase we
Yeah.
go through when we're in kindergarten, in primary school. But I study dinosaurs for my job. I'm a paleontologist. I'm a professor at the University of Edinburgh. It's my job to dig up dinosaurs, study dinosaurs, teach about dinosaurs. And we've learned so much about dinosaurs, especially recently. I think there's a great story to tell. These are not just for kids. We can learn a lot about our world, the history of our world, through studying dinosaurs.
Yeah, I mean that was the fascinating thing. I mean, being like a human dinosaur myself. I mean, the first time first time we got into dinosaurs in the 1960s as a kid, there was about 10 different species then, and it's a very narrow idea of the whole story. And there's still arguments what they got wiped out, but now we know they kind of morphed into birds. And there's a whole other tale now. And when I read your book, it was fascinating how much more we know now about the story. So would you say that we're kind of close to getting a picture, or we just scraped a bit more of the surface?
I think we're still scraping the surface, to be honest. It was only 200 years ago, exactly. Early winter 1824, the first dinosaur was given a formal scientific name and formally described by a scientist and put on display, and that was Megalosaurus in England. It was in London where this all went down. So, really, scientists have only been looking for dinosaurs and studying dinosaurs for 2 centuries, which is not a really long time, frankly. But during that time, we've learned a lot. And we've especially learned a lot over the past 2 or 3 decades. This is where the field has gone into hyperdrive. And you're totally right. When you were young, when I was young in the 80s growing up, and the books we had in school at the library, it was T Rex, Brontosaurus, Triceratops, Stegosaurus, those classic dinosaurs. But now we know over 2,000 species of dinosaurs. Somebody's finding a totally new species on average every single week. So there's about 50 new species that come to light every year. This is because there's more paleontologists than ever before. There's especially a lot of young people all around the world. China, Brazil, Argentina, South Africa, Mongolia, these enormous countries that are growing, developing, building new universities, building new museums. It's young scientists in those places more than anywhere else that are going out and driving this field. So we are still scratching the surface. There's still a lot to be found, but we have learned so much more in the last few decades. And we've not only found new dinosaurs, but we of course love to use all kind of technologies and techniques and methods, whatever's at our disposal, to study these million-plus-year-old fossils to understand what they were like as real animals. And there have been many breakthroughs in that area as well.
Yeah, because even I mean, that was what's interesting in the book. The new technologies used to work out what these things even look like has changed actually what they look like as well, hasn't it? Because now it seems like a large chunk of the dinosaurs are actually feathered or primitive proto feathers or whatever. And to me, that's just the weirdest idea. I think the idea like that. What's that? That is it the hell chicken? It looks
The hell
far more
chicken, yes.
the Anzu, but it's far more terrifying than a T Rex. The idea that this
I
kind of
agree.
slightly camp looking thing with like massive like razor blade like claws running around is like a nightmare, and it's like something's been made up by a Hollywood director.
Yeah, or a glam rock dinosaur. Maybe some of them are punk
Yeah.
rock dinosaurs. A lot of them are rock and roll dinosaurs. But seriously, like you look at these dinosaurs now and what we know a lot of them did have feathers. Today's birds evolved from dinosaurs, and Dinosaurs actually invented feathers, and a lot of dinosaurs were covered in all kinds of crazy plumage. Some even had wings. Some had weird feathers sticking out of their tails and feathers on their legs, all kinds of things. We can even tell the colors of some of those feathers now if they're well preserved. You can put them under really powerful microscopes, and you can see these little bubbles. These things are called melanosomes, and that's the technical term for the little things that hold pigment, and pigment is what gives color. So we know by comparing with modern day animals, looking at those little bubbles, the size and shape of those bubbles differ depending on whether it's brown or black or white or ginger or whatever. We can tell that dinosaurs had all those different types of colors. Some dinosaurs had crazy patternings on their bodies. Some were camouflage, some were counter shaded, so they were darker at the top and lighter at the bottom to hide from predators. There's a dinosaur that had a ringed tail, kind of like a raccoon. There were dinosaurs that had iridescent feathers, so like crows and ravens today, the feathers kind of glitter in the sun. Dinosaurs could do that. So I really think that this new image of dinosaurs, I think it makes them both more terrifying in some ways, as you say, and to me, an enormous bird is one of the scariest things to think about in the
Yeah.
world. But it also, I think, makes them cooler, makes them funkier, makes them more fun. It gives them that kind of rock and roll edge, and it means we can be imaginative. Back those books, probably the same with you when you were growing up. Certainly, the ones I had, all those dinosaurs were green or brown or gray. They were boring. And that's not what dinosaurs were like at all.
I mean, I was reading somewhere the other day, the fact that the birds come out of dinosaurs, and in a sense, we still are weirdly in the age of the dinosaurs. You could argue because the birds are probably one of the most successful, creatures on the planet of the moment, that the age of dinosaurs maybe didn't actually really end when the asteroid hit.
That's true. That's absolutely true. So 66 million years ago, this 6 mile wide rock fell out of the sky, big asteroid, one of the biggest to ever hit the Earth, and it led to chaos. I mean, it unleashed more energy than a billion nuclear bombs put together, if you can even try to imagine something so destructive. And it unleashed earthquakes and wildfires and tsunamis and all kinds of destruction. And the dinosaurs had been around for a long time up until that point. They were dominant. They lived all over the world. They were the biggest plant eaters and meat eaters and food chains all over the world. And then almost all of them died really quickly. Not instantaneously, but probably within a few thousand years or so. But only one type of dinosaur was able to live on, a peculiar type of dinosaur, a small dinosaur that could grow really quickly and hide easily and eat seeds with its beaks and fly away from the danger. And these were the birds. These were these offshoots of dinosaurs. The same way bats are offshoots of mammals. Bats are a weird type of flying mammal. Birds are a weird type of flying dinosaur. They were the only ones that had what it took to survive that chaos and carnage. And today, birds are still with us. There's over 10,000 species of birds. There's about 6,500 species of mammals, give or take. And we like to think of today as the age of mammals. We are a mammal. Mammals rule the world. And yes, there's whales and elephants and all kinds of big mammals, spectacular mammals. But if you go by raw number of species alone, there's still about twice as many dinosaurs as there are mammals living today. So I think we need to pay the dinosaurs their respect.
It's interesting that all these kind of the major animal groups have all been sort of coexisting from before the period of dinosaurs, haven't they? And each one seems to get to the top of the food chain, then it goes back a little bit. I mean, the beginning of the age of dinosaurs, the dinosaurs were not even the main. They weren't the top, were they? Would it be the crocodiles, and that end would be the top for millions of years, wasn't it?
Yep, you got it. And the dinosaurs for a long time were underdogs. That, to me, makes their story even more interesting. When the first dinosaurs appeared, this was about 230 million years ago, back in the Triassic period. This was a time when all the land was gathered together as one, the supercontinent of Pangaea. All the land, one giant landmass that stretched from North Pole all the way down to the South Pole, surrounded by one global ocean, a totally alien world to us. Dinosaurs emerged on that world, and when they did so, they didn't look like T-Rex or Brontosaurus, not right away. It took many tens of millions of years for dinosaurs to navigate things, to deal with other groups of animals that were their competitors, to outlast those competitors. Crocodiles and early cousins of crocodiles, giant amphibians, salamanders the size of cars that would have ruled the rivers and the lakes. This was and not just an alien world. This was a fantastic world. I mean, imagine these creatures. Some of these crocodiles were top predators. There were crocodiles that looked like T-Rexes, kind of, just a little bit smaller. There were other crocodiles that ate plants. There were crocodile cousins that had sails on their backs, they had beaks. There were other crocodile cousins that ran on their hind legs only. It was a crazy dream world of bizarre crocodiles and giant amphibians. And the dinosaurs were just this little role character in that world. They were like a B-list. I wouldn't even say B-list, C-list. They were the way underbill in the music festival. They were the one, on the third day at the 9 a.m. slot or something. They were nothing. And it took them a long time to just navigate that kind of world. But dinosaurs, they had a lot of things going for them. They were quite energetic. They had pretty high metabolisms, probably. They had fairly large brains compared to other animals at that time. A lot of them could run pretty fast. They could move easily. So they had a lot of advantages. It just took them time for those advantages to win out. And what really did it was about 200 million years ago. So a good 30 million years after the first dinosaurs were blossoming, there was an extinction, a big time of extinction, not caused by an asteroid like the end of the dinosaurs. But this extinction was when that big supercontinent of Pangaea was beginning to break apart. And of course it broke apart. That's why we have separate continents today. But now the ocean, fills the gaps. The Atlantic Ocean separates, South America from Africa. They look like puzzle pieces. That's because they did used to fit together. Then the ocean came between. But before the ocean came in, there were huge volcanoes that erupted all along those crack zones as Pangaea was splitting. And that led to really rampant climate change. It led to a big extinction. And that extinction, it decimated a lot of those crocodiles, a lot of those giant amphibians. Dinosaurs were the success stories, the survivors of that extinction. We don't really know why, but somehow that extinction wiped away a lot of the competitors to dinosaurs. It gave dinosaurs this opportunity to prosper in this now largely empty world. And in the next interval of time, which is called the Jurassic period, that's when dinosaurs really grew to huge sizes and became incredibly diverse. And that's when all of these dinosaurs with horns and spikes and frills and duckbills and dome heads and wings and all of these fantastic things we think of when we think of dinosaurs, that's when those dinosaurs evolved. So the story of dinosaurs, the origin story, is a humble one, an underdog story, but they made it through and then they became incredibly sublime in every way.
I mean, is this part of the pattern of nature? When you become the dominant species, one, you become really huge, like in sizes that we can't even imagine. And the other one is you become really diverse, with all these weird shaped heads and fins and loads of extra coloured feathers. Is it like almost like a decadent period? You have time to actually get fancy.
There is something to that because the way, evolution doesn't really work with a plan. Evolution can't plan ahead of time. Evolution by natural selection, the way it works is, it just adapts organisms to their situations, to their surroundings, to their realities, the here and now. And then over time, of course, adaptations, things that evolve, things that change can kind of build up and allow organisms to become successful. Almost by chance, and birds are a good example of that. It's not like evolution made some master plan that, millions of years in the future, we're going to turn a dinosaur into a bird. It's just that, no, the first feathers evolved as simple little hairy strands, probably to help these dinosaurs keep their bodies warm. Some of the first dinosaurs would have had feathers like you. Not so much like me. I'm losing it here. But that's what the first feathers looked like. And there were actually dinosaurs, and I kid you not, with like Mohican type, crest and feathers. They were there for display to attract mates and intimidate rivals and to keep them warm. And then later on, some dinosaurs turned those into wings. Probably not for flying, not at least not at first, but as advertising billboards sticking out of their arms saying, "Hey, I'm scary, I'm big," or "Hey, come mate with me," that kind of thing. And then later they were co-opted for flying. And so that's kind of how evolution works. It just doesn't plan ahead. It works in the moment, but over time things can happen almost by circumstance. And so many of these successful groups, whether it's dinosaurs or what we see around us today, giant mammals, whales, elephants, even us, we have humble origins. We don't start that way. We start small. Evolution kind of builds up over time. And then some groups can become incredibly diverse, incredibly successful, grow to huge sizes just because they've happened on something. They've evolved some new feature that unlocks a potential or that allows them to live in a new way or live in new environments. And then oftentimes those groups can become very diverse or very big, and then they do kind of reach a stage sometimes where, they're just so utterly dominant, but they're so well adapted to their own world that if something changes, like if a giant asteroid falls out of the sky, or a lot of volcanoes erupt, or there's very rapid climate or environmental change, those groups can almost be like too well adapted to their world that they can't change so quickly. And it's in those moments of upheaval that we often see smaller animals, more humble animals, things that are resilient, things that are adaptable, things that have had to live in the shadows, that have had to deal with being those B-list or C-list characters. That they're the ones that have what it takes to endure. And then after that, imagine, you're one of these furry little mammals or one of these little birds that survived the asteroid, and things calm down, the fires die down, the tsunamis stop, the earthquakes stop. You look out at this world and there's no T-Rex anymore. There's no Triceratops anymore. That world is now yours. And so much about the history of life is like that. And I think that makes it a great story, and a story that we can really relate to.
And it's interesting, isn't it? Because evolution isn't a curve, is it? It's not like, it's not like each epoch isn't, it's getting better than the last one. It's just a reaction to the environment that you're currently in. And that's a lesson that's quite powerful that we need to learn, really, isn't it?
Absolutely, because of course our world is changing very quickly today. We see it. I mean, we see it. We see it in more powerful storms that seem to be in the news more regularly. We see it in some of these extreme temperatures that we're seeing in the summers. We also see it in some of these extreme temperatures in the winters. It's not just that everything's getting warmer all the time everywhere. It's more extreme. And we know why this is happening. Humans have played the dominant role in this, our effect on the world. There's like 7 or 8 billion of us, and we put a huge stress on this planet. Now, a lot of the things that are happening now, global warming, rising sea levels, these sort of things, they've all happened before. They've all happened before. The Earth is 4.5 billion years old. And so none of this is new. What's new is the cause. And the pace of it, the speed of it. A lot of these things are happening so fast. Things are happening now on the scale of decades or centuries that would have taken tens of thousands, hundreds of thousands of years before. But the point is, we can look at dinosaurs, we can look at other fossils, we can look at that record we have of the history of the Earth, and that gives us perspective. And I hope it gives us a bit of humility. We are the dominant species today. Yes, we are. So much so that we're affecting the world in all kinds of destructive ways, and in good ways too, of course. But there have been dominant species before. The dinosaurs were among those. I mean, if you were a T-Rex and you woke up that morning that the asteroid hit, you would have no idea anything was going to happen. You were a 40-foot-long, 8-ton, top of the food chain, bone-crunching monster. You could eat whatever you wanted. You were the dominant species, and before long you weren't. And why? It's because the world changed very quickly and you couldn't adapt.
I mean, yeah, and it's a powerful lesson, and also the asteroid. I always think it's quite fascinating because it does create lots of what ifs. If the asteroid had gone like a couple of million miles to the right of the planet Earth, the dinosaurs would have carried on, wouldn't they, and developed? I mean, do you actually like play little games in your head of what would have actually they morphed into a couple of 100 million years later?
All the time. I think about this a lot because it's fun. It's fun. When we dig up fossils, we find these creatures that don't exist anymore. That if we didn't have their fossils, we would never know. If we didn't have
Mm.
fossils, we would never know something like a T Rex once lived or a Brontosaurus. An animal heavier than a Boeing 737 plane with their big bellies and long necks, and so you would never know that existed. And so that also means that we like to think about what might have evolved had things been differently, or what might evolve in the future of our own world. And I do think you're right that if that asteroid didn't hit the Earth, things would have been very different. And let's face it, that asteroid was just a piece of space junk. It was just
Mm.
this rock hurtling around through the heavens. It could have gone anywhere. And it just so happened to make a beeline for the Earth. And if things were a little bit different, if that asteroid just sailed right on by, it just rustled the upper layers of the atmosphere, and that was that, no dinosaur would have ever known.
Mm.
And at that point, dinosaurs had been around for over 150 million years. They were dominant animals. They were very successful animals. They were the biggest animals at the top of the food chain, but there were many other species throughout the food chain. It wasn't just that dinosaurs were all big and scary, it's that they did many things. They were very diverse. And so I don't see any reason why dinosaurs would not have continued if the asteroid didn't hit. And this asteroid, this was the biggest asteroid to hit the Earth in at least the last 500,000,000 years. This was not a normal thing. This was that kind of curveball that came way out of nowhere. And maybe we all have things in our own lives we can kind of think of, little analogies. Just something dramatically happens one day in the course of your life changes. And I think that's what it was with the dinosaurs. So if it didn't hit, I think dinosaurs would have persisted. Now, they would have continued to evolve and adapt. It wouldn't be that T Rex would still be here today, but T Rex would have had to evolve and adapt, and Triceratops and so on. But I do think you'd still have many, many more dinosaurs in today's world, not just as birds, but big dinosaurs, the classic big canonical dinosaurs that we all think of. Mammals, I don't know what mammals would be doing. I don't know if we would be here. Probably not. Mammals also originated way back on that supercontinent of Pangaea. The mammal origin story is the same as the dinosaur origin story. They go back 230 million years ago. But dinosaurs went big. Mammals had to stay small. They were relegated to the shadows. The dinosaurs kept them that way. But mammals were very successful at being small, at living incognito, at living underground, at living in the underbrush, at coming out at night, at surviving in this world where dinosaurs ruled. And if the asteroid never hit, I don't know if mammals would have had their chance to break out of that. They might have stayed small. They might have stayed humble. They may have not got their big break. and so in our world today, if that asteroid never hit, I would think there probably would be a lot more big dinosaurs. Mammals would probably still be pretty small. But who knows? And this is the fun, right? We can all think about this what if story, and I think that is just a whole lot of fun.
It's interesting because mammals still do occupy, generally, most of the species are nocturnal, living in burrows, scurrying around in the shadows, aren't they? There's only a few like freaks that manage to sort of turn into what eventually us, isn't there? Like generally mammals are still twilight creatures, aren't they?
Yes, absolutely. The vast majority of our mammal cousins are still small. The vast majority are things that hide away. You don't see them very much. They come out at night. They're nocturnal. I mean, something like 40% of mammals today are bats, and we hardly ever see bats because they mostly come out at night and they're very good at just hiding away. That is what most mammals are like. Most mammals retain that kind of lifestyle they had when they lived with dinosaurs. But what the asteroid did was it unleashed the possibility or unlocked the possibility, let's say, for mammals to become bigger and to diversify into those larger roles in their ecosystems after the dinosaurs died. Those roles at the top of the food chain, the biggest animals, the biggest meat eaters, the biggest plant eaters. Mammals could now start to fill some of those roles. Not all mammals, but just some. Those roles became open to them. And that's where you eventually see, bigger ones, dogs and cats and elephants and whales. and kangaroos and just all these larger mammals you can think of. But you're absolutely right that most mammals today are still doing what they were doing during the time of dinosaurs, and I think that should give us some appreciation for that long period of history, well over 150 million years, when our ancestors were literally living with the dinosaurs.
I mean, towards the end of the dinosaur period, were they changing? I mean, I did read some things that the dinosaurs were in decline, but that's a bit of a controversial topic because I've also read articles where people say the dinosaurs were diversifying as much as ever. I mean, what was actually happening just before the asteroid?
I'll tell you, John, you're up to date in your dinosaur research. You've got a pulse on the field because it is a big debate. I'm pretty confident that dinosaurs were going strong until the end. One of the problems is, up until recently, there have not been a whole lot of fossils of dinosaurs from that last million years or so before the asteroid hit. The fossil record is far from perfect. Okay, the vast majority of anything that ever lives is not going to get buried in sand or mud and harden into rock and turned into a fossil. I don't think that's the fate that awaits either of us, let's say, or the vast majority of things. So, as paleontologists, we really are kind of like detectives at a crime scene where there's some evidence, but just little bits of evidence here and there. We have to make do with what we have. And oftentimes it's good enough to flesh out the general story, but sometimes there are big gaps. And for a while, there was this big gap. It was really only fossils from the western part of the US and Canada that came from this final million years. And those fossils show dinosaurs as quite diverse. That's T-Rex, that's Triceratops. Those famous dinosaurs come from exactly those rock layers. They were there the day the asteroid hit. But we didn't really know in Europe and South America and Asia what dinosaurs were doing. Well, there's a lot of new discoveries now from that time interval. And some of the best ones are here in Europe. You might think, oh, we found all the dinosaurs in Europe, but no. Even though people have been looking here for centuries, there's still a lot to be found. And in places like Spain and France and Romania, Bulgaria now is a new frontier. These all have dinosaurs from the very end, right before the asteroid. Now, back then, Europe was just a set of islands. The sea levels were so high, most of Europe was flooded. It was only like today, what's the mountains that stood out as land. But there were different dinosaurs living on all these different islands, including some really wacky ones, including little dwarf species, because oftentimes animals get smaller if they live on islands because there's less space, fewer resources, and so on. So dinosaurs seem to have been going well in Europe. Lots of species, different ones on different islands, meat eaters, plant eaters, adapting to those islands, getting small to adapt to the islands right up to the end. Asia, South America, it really looks the same. The growing record is there are quite a lot of dinosaurs to the very end. Now, some people might still argue there was some kind of decline. Maybe there were fewer species of dinosaurs than there were 20 million years earlier or 50 million years earlier. I mean, that is very possible. But if by decline you mean that dinosaurs were in serious trouble, that they would have gone extinct anyway, that the asteroid didn't really do it, I don't think so. I really think that the evidence is strong and becoming stronger, that dinosaurs were struck down either in their prime or pretty close to their prime. So that's where I think things are. Some people might debate with me. It's a good debate. It's great that we still have these friendly debates in paleontology, like any science. It keeps things fresh and it keeps us on our toes and makes us go out and keep finding new fossils.
Another interesting thing is the book was about the diversification of species. Was again the old model, the stuff you used to read about years ago. There'd be like a brontosaurus in a swamp. There's a T-Rex lurking around the corner, and that was the whole planet. But of course, that wasn't like that, was it? Wherever you went on the planet, there was different species, different ecosystems, like there is now, isn't there?
Exactly. And when we think of the age of dinosaurs, we should think about what the Earth looks like today. Now, the Earth is quite different today. The Earth was a lot hotter during the time of dinosaurs. The sea levels were higher. There weren't ice caps at the poles. The continents were in different positions. But the key thing is that just like today, there would have been different dinosaurs that were living in different places, that were adapted to different climates, different environments. Then as that big supercontinent split apart, the dinosaurs were along for the ride. And they evolved as the individual continents were breaking up and moving around. And so there were dinosaurs that lived In the tropics, there were dinosaurs that lived at the poles. There were dinosaurs that lived in mountains. There were dinosaurs that lived along rivers, along lakes. There were dinosaurs that lived in lagoons. We have fossils of them here in Scotland. We have fossils on the Isle of Skye, and we've been collecting those for about a decade, ever since I moved to Scotland from America. And we have, for instance, a site we found a few years back. It's a footprint site, a track site, and we have over 100 footprints and handprints that were made by one of these giant long-necked dinosaurs, like a cousin of Brontosaurus. And these tracks, 170 million years old, Jurassic in age, they were formed at a time that Scotland, I kid you not, but it was a subtropical island. And I'll tell you, this morning is not subtropical. But, we have to go back and think how the Earth has changed, and that's what Scotland and all of Britain was like at that time. And these dinosaurs were living in this subtropical island paradise, really, and they were making their handprints and footprints as they were wading through the shallow water of a lagoon. And we can tell that from the rocks that they made the footprints in. And we found these at a place called Duntullum. It's on the far north tip of the Isle of Skye, and you can go see them. Anybody who's listening, if you ever go over to Skye, there's actually several dinosaur track sites. You can go along the east coast, north of Portree, where you can literally walk in the footsteps of dinosaurs. But I think this goes to show, dinosaurs wading in a shallow subtropical lagoon, maybe that's not the image that we think of when we think of dinosaurs, but that's one of many environments that they would have lived in.
But also, in the diversification of species, it's not just all the big giant superstar dinosaurs. There's lots of like weird little small ones. I was reading about one the other day that hung off branches off a tree and with his tail, a little hook on his tail, with his mouth open catching flies, which is it's not the classic image of a dinosaur you had when you were growing up, is it? There's, because the science is better now and the detection is better, we can find these smaller species. And were dinosaurs, did they have that range, from like tiny mouse-sized dinosaurs to huge lumbering double-decker dinosaurs?
That's what made dinosaurs properly, truly so successful. It's not that all of them were huge. No, it's that they had a range of sizes, and they range from fairly small, and if you count birds in the equation, really small, all the way up to things that were heavier than 737 airplanes. That is remarkable to me, that dinosaurs had the potential to grow to such extremes in size. They had such variability in size. They had this ability to adapt to their different ecosystems, their different environments, and achieve all kinds of different sizes, but not just sizes, body types, body shapes, diets, behaviors, ways of moving. And that diversity is, for me, as a scientist, what really makes dinosaurs special. I know we latch on to the big, iconic, hyperbolic ones. And me too. I study T-Rex. T-Rex is one of my specialties as a researcher, and it is my favorite dinosaur. And I know that's a cliche, and I know that's what every 5-year-old says. And I know you probably expect a scientist to give you some more intellectual answer there. But no, I love T-Rex. I do love the big dinosaurs. But what really impresses me about dinosaurs is, as you say, they did so many things. There were little dinosaurs that ate bugs. There were dinosaurs, ones you could hold in the palm of your hand, that had wings made out of skin that they used, probably to glide between trees, kind of like the wings of bats. This is probably a separate experimentation in dinosaurs flying, birds, modern birds being the other one. There were dinosaurs that specialized in eating all kinds of different foods. There were dinosaurs with weird types of beaks, dinosaurs with strange crests on their head and different types of feathers. There were, of course, enormous dinosaurs, all the way down to tiny ones that could burrow. There were dinosaurs that could dig burrows and hide out in those burrows. There were dinosaurs that had domes on their heads that they probably used to headbutt each other, or at least kind of, wrestle each other. I could go on and on, but really it's the diversity of dinosaurs that really made them so special.
I mean, you say there's we find a lot of dinosaurs, but we're still scratching the surface. But with what we got now, can you kind of extrapolate that and sort of, I know it's not very scientific, but make a guess of the missing ones? There's obviously a gap here. There probably was something that did this that looked a bit like that. Is that something that you would do as a scientist?
Absolutely. We are always thinking about where our gaps in knowledge are, and we're trying to fill those. And I think the thing about paleontology is that when we go out and look for fossils, we never really know what we're going to find. It's very much a discovery science, and it is kind of like prospecting for gold or diamonds or something like that. You can do your homework, you can figure out where to look, or maybe somebody else has found something, so you know there might be something over there. You target rocks of the right age and the right type that might have dinosaur fossils, but then you go out and you look, and there's no fancy technology. There's no sonar we shoot into the rocks to see where the bones are. You just have to walk around and see if something interesting looking is sticking out of the rocks. And if so, you look further and get out your tools and dig deeper. So we never really know what we're going to find. So it's hard for us to say, I really want to go out and find a dinosaur that's 100 feet long and has 6 arms and fire, whatever. Although there's all kinds of fantastic dinosaurs we'd like to find, what we more try to do is say, well, we don't know much about this part of history. We don't know a whole lot about the middle part of the Cretaceous. There's not a lot of fossils. So let's try to find rocks of that age and just see what dinosaurs are there. Or we don't know a lot about the early history of some major group of dinosaurs, let's say the long-necked dinosaurs. So let's go and try to find fossils in there. Or we don't know a lot about dinosaurs from a certain area, a certain landmass. Let's go and find fossils there. So there's a lot of gaps there. There's a lot still to be found. I think to put it into perspective, we know of about 2,000 species of dinosaurs. These have been found and named and described over the last 200 years by scientists all over the world. Now, in today's world, birds, living dinosaurs, there's between 10 or 14,000 species, depending on who you ask. There's a lot of little debates about whether two things really are different species. Is their DNA different enough? Do they reproduce with each other or not? Those kind of things. But let's just say 10,000. So that means there's 10,000 dinosaurs alive today. That's 5 times the number of ancient dinosaurs that scientists have found. And now dinosaurs lived for well over 150 million years. So just do the maths there. If there's 10,000 dinosaurs alive at this point in time, think about how many. We're talking about hundreds of thousands, probably millions of different species. We found a tiny, tiny number. Some of those species maybe never left any trace, never ever turned into a fossil. Others, many others, surely did turn into fossils, and they're waiting, lurking somewhere in some rock, somewhere around the world for somebody to find them. So there are big mysteries out there that we need to solve, including why dinosaurs survived that great extinction 200 million years ago that killed off so many of the crocs and giant salamanders. We don't really know. That's a big mystery. And there's so many new dinosaur species to be found. So for younger people that might be listening, or for parents of people that are kids that are into dinosaurs that might be listening and think, is this field dead? Is this field going extinct? No, it's not. There's tons still to be found. The fact we're still finding new dinosaurs in Scotland, here in Scotland, a country that's been developed for such a long time, that tells you, I think, all you need to know. There is stuff to be found out there. We need more people looking.
I mean, obviously we've got the superstar dinosaurs we discovered so far, but I mean, because it's an incomplete fossil record, could there be like bigger and crazier apex predators and the T-Rex? Could there be larger, more lumbering brontosauruses out there?
Yes, definitely. Yeah, we need to keep our minds open. Who knows? We found this tiny fraction of all the dinosaurs that ever lived. And as we've seen over the last 200 years of research, somebody finds a big dinosaur, says it's the biggest in the world, then somebody finds a bigger one, then somebody finds a bigger one. Yeah. And so a few years back, the new record holder is this animal called Patagotitan from Argentina, from down in Patagonia, discovered by a shepherd and excavated, dug up by a colleague of mine, Diego Pol, great scientist in Argentina. And it's huge. I mean, this thing was heavier literally than a Boeing 737 plane. It was over 100 feet long. I mean, longer than a yacht. But there are rumors now, and I don't know if they're true or not, but there's rumors now of something bigger. And it wouldn't surprise me one bit. So who knows what's still out there waiting to be found? I find that incredibly exciting.
So, as an expert on the Tyrannosaurus Rex, Perhaps you can finally ask the question. Answer the question I've always wondered. What was going on with his arms?
I'm glad you asked because right now, we're back here at the university for the new semester. One of my good colleagues, great young scientist named Greg Funston, is here to work with us, and we have a project ongoing about this. We are writing up as we speak, literally this week, a scientific paper about this, about our ideas. We've done a lot of analyses. We've looked at trends in the size of the arm of tyrannosaurs over time. We've looked at the muscles on the arm of T-Rex because muscles leave marks on the bones. We're still trying to figure out the whole story, but basically, those arms of T-Rex, they were tiny. Okay, they were the length of our arms. T-Rex was the size of a London bus. So a London bus with our arms sticking out of it is the weirdest thing. I mean, totally
Yeah.
nuts. But those arms were a lot more muscular than our arms. And it was really the muscles that kind of, brought the arms towards the body this way that were particularly strong. So those arms were doing something. They were not useless. They would not have been good for grabbing prey or slashing prey, but maybe for holding the T-Rex, bracing it as it ate, or maybe during mating, something like that. We're still trying to figure out the story. There's no doubt that a lot of big meat-eating dinosaurs that evolve huge size and evolve big heads kind of have the arms do the opposite. The arms get smaller as the heads get bigger. So there's probably something to that, some kind of evolutionary trade-off. So we're trying to sort it out, but it's a question that fascinates us too.
And I would be able to work out what the level of intelligence was. I mean, again, when I was younger, the model was that these were just big lumbering idiots. But as time's gone on, people realise that they're pretty intelligent, aren't they? The upper end dinosaurs.
This is one of the new revelations. A lot of dinosaurs were smarter than we used to think. And this is something we study here in my group in Edinburgh. We're a part of a big new project now working with another paleontologist named Larry Whitmer, who's one of the world experts in dinosaur brains and dinosaur anatomy generally, and an actual cognitive biologist who studies modern day ravens and crows and ostriches and crocodiles, a guy named Matthias Osvath in Sweden, and then a neurobiologist, a guy who studies actually the tissue of the brains, the neurons of the brains, Pavel Niemek in the Czech Republic. We've come together. We got a project. We're trying to figure out how much we can actually say based on real fossil evidence about how smart dinosaurs were and how they sense their world. And the more we look, the more confident we are that some dinosaurs were pretty intelligent. And why we think that is because we can CAT scan the skulls of fossil dinosaurs. And we can use the x-rays of the scanner to see inside those skulls, just like a medical doctor might with us. And we can use software. We can build digital models of that brain cavity. And we can essentially build a digital model of the brain. And we can measure the size of that brain and look at the shape of that brain. And that tells us that a lot of dinosaurs had pretty big brains for their body size, at least compared to like other reptilian type of creatures. So compared to say crocodiles or geckos or whatever. So we think they were probably smarter than we used to give them credit for. And some of them, like Velociraptor, the ones that are very closely related to birds, they're probably quite smart because today's birds are very smart. They have huge brains for their body size. They also have tons of neurons packed into those brains. And we can see these small meat-eating dinosaurs that are also evolving wings and these other features of birds. They're also getting bigger brains. So some of those dinosaurs like Velociraptor were probably very smart, maybe similar to the intelligence of at least some birds today or some mammals today, but we have a lot to learn. And this is really the big research project we're turning our attention towards here in my lab and with my colleagues and with my students.
So speculation again, but would it seem that the sort of the more intelligent, faster moving bird-like dinosaurs, eventually by adding flight to what they already had, would have been where the dinosaurs were possibly maybe evolving towards?
Yes, I think if you want to do the imaginative speculation,
Yeah.
the asteroid never hit. Certainly, some dinosaurs would have continued to get smarter and smarter. And since we know that already, because today's birds are dinosaurs, they've evolved from dinosaurs, they have gotten quite smart. So I would surmise, and I could be wrong, of course, but I would surmise that maybe some of these other dinosaurs, like the raptor dinosaurs, not flying, not true birds, but close relatives, they might have independently gone off on their own and evolved into species with bigger brains and higher intelligence. But who knows, really? Maybe not, or maybe at the other extreme, some of these dinosaurs may have even eventually evolved human type levels of intelligence. Who knows, really? We don't know.
Yeah.
And again, that makes this all a whole lot of fun.
So, and finally, what kind of noise did they make? Would there be like a dinosaur dawn chorus? I mean, I did read somewhere that so far on the fossil record, they're not. It's hard to find anything that they could have made a noise with. But I do like the idea that this kind of bizarre, booming, honking, shrieking dawn chorus of dinosaurs. I'd just love to hear it, actually. Yeah.
Yeah, when you watch the films, the dinosaurs are always roaring. They always all sound like angry lions, and that's probably not what they would have sounded like. That's a more mammalian way, and of course, not even all mammals vocalize that way. But that gives them, I think, some extra fright factor in the film. But in reality, it's hard to know exactly how a T Rex would have sounded. We have very minimal evidence. There's a duck-billed dinosaur called Parasaurolophus. It had a big old crest of bone that actually stuck out from its nose over the back of its head. And it was a pipe, really. And you'll enjoy this. You'll like this. There was a paleontologist, a dear friend of mine, Tom Williamson, in New Mexico. He teamed up with some physicists at one of the national labs in America. They use software, kind of like how instrument makers and designers will use software if they're designing a new instrument. They want to make sure that it actually sounds the way they want it to sound. In reality, they use this kind of technique to predict the noise that would have been made by that head crest if air passed through it. And they produce this pretty low bellow. So something that's kind of like a tuba, something like that. That's at least how those dinosaurs probably sounded. Now, a T-Rex wouldn't have had that big resonating chamber sticking out of its head. It would have used its throat to vocalize. We don't really know what it sounded like. There are some fossil birds where the voice box is even preserved. There's one called Vagavis, this bird, a colleague of mine, Julia Clark, who's a great expert on early birds. She and her team discovered this in Antarctica. So we find stuff in Antarctica now. The voice box was preserved. So these primitive birds living with dinosaurs in the Cretaceous period would have been able to tweet and chirp and sing similar to birds today. And maybe things like Velociraptor could have as well. So that's a nice thought, I think, to end with, that if we were there in the age of dinosaurs, I think there could have been a chorus, a melody. There could have been dinosaur musicians. and it could have been capable of all kinds of sounds.
Oh, brilliant. Well, thanks for your time, Steve. That was really great. Yeah.
Yeah, my pleasure, John. This is a lot of fun. It's really cool to connect.